Today in class, I introduced you to the idea of dimensional analysis with that Weebly site where you're moving the boxes around to do unit conversions. So I just wanted to make sure that we all were clear on the procedure that we follow for this sort of problem because it's a very important problem to be able to know how to solve. We'll be coming back to this specific way of solving unit conversion problems all year long. So if we have a question that says, for instance, how many miles will a person run during a 10-kilometer race? Really, all these dimensional analysis problems can be written of the form convert x to y. And we've just got to figure out what x is and what y are. So in this question, we're being asked to convert 10 kilometers into miles. So convert 10 kilometers into miles. So to solve this sort of problem, we first start with what we're given. We start with the x. So 10.0 kilometers, and I'm just putting it over 1 so that it fits the dimensional analysis form. Okay, and then we say, okay, so how can I get from kilometers into miles? Which unit conversion am I going to use? So if I see right here, 1.00 kilometers is 0.621 miles. So I write that unit conversion factor this way. The reason I do that is I want to get a number at the end that is numerically equivalent to 10.0 kilometers. I want something that is equal to 10.0 kilometers. So the only way I can multiply 10.0 kilometers by something and get the same amount back is if I multiply by 1. So if I say 1 kilometer is equal to 0.621 miles, and I put kilometers on the bottom and miles on the top, I essentially am multiplying by 1. But let's see what happens. When I put kilometers at the bottom, I actually end up crossing out kilometers. If I can treat my units like variables, which I can, kilometers on the top and kilometers on the bottom causes the kilometers to cancel out. So my answer is the same number, but written in miles rather than kilometers. So I've essentially crossed out a variable by dividing by that variable, and then, but that variable is part of this larger term that is basically equivalent to 1. So let's see if we can do that for another problem. So for this question, it says how many hours are in 2.00 years? So again, I'm trying to convert x to y. So I am, in this problem, converting 2.00 years into hours. So again, I start with my x. I start with the amount I'm given, 2.00 years. And ultimately, I want to get something that is equal to 2 years, but expressed in hours. So I really have to multiply by 1 a bunch of times. Now let's see where I can go. I don't have a conversion factor up here that converts years directly to hours, but let's see if I can convert years into a smaller time unit and then work smaller and smaller. I can convert years into days. 1 year is exactly 365 days. So if I put years at the bottom and days at the top and have this conversion factor such that I'm basically multiplying by 1, I can cancel out my years, and so I'm going to end up with an answer in days. Now let's see. Can I get days into hours? Well, as a matter of fact, I can. 24 hours are in 1 day. So if, again, I put days on the bottom and hours on the top, I get something that's equivalent to what I had before because I'm multiplying by 1, but it's expressed in terms of hours. So my answer is 1.75 times 10 to the 4th hours. And if you did that on your calculator, you'll see that I'm rounding to the nearest hundredth. That's because this is rounded to the nearest hundredth, and we'll get to the rules for that later. But hopefully now you can see how we convert something like 2 years into hours. So you may ask, do I have to use this method? Do I have to write it exactly this way? And the answer is yes, you do. You may be able to do these kinds of problems in a different way, but soon, and very soon in this year, we're going to be doing much more complicated problems that are really going to require you to keep careful track of your units. So you really want to make sure you learn this method of solving this kind of problem. So our final example is 60 miles per hour is how many feet per second? So we're being asked to convert miles per hour to feet per second. 60 miles per hour to feet per second. So we do have a bit of a problem here because we have essentially two units here. We have miles and hours that we're trying to convert into feet and seconds. So the way we're going to solve this is by converting one at a time. So we start with 60 miles per hour. Now look at the way I wrote this. 60 miles per hour means I travel 60 miles in 1 hour. 60 miles per hour is 60 miles divided by 1 hour. So whenever you see this kind of unit that is 1 unit divided by another unit or 1 unit per another unit, you put the first unit at the top and the second unit at the bottom. 60 miles per hour is I travel 60 miles in 1 hour. So the first thing I'm going to do is I am going to convert miles into feet. So I'm going to go 60 miles, and as you can see up here, 1 mile is 5,280 feet. So I have miles at the bottom and feet at the top, and I can cross out my miles, and I'm going to get something equivalent to 60 miles per hour, but this time it's expressed in feet per hour because my hours haven't canceled yet. But now let's see if I can convert my hours into seconds. So here we are. 1 hour is 60 minutes, and we cross out hours. 1 minute is 60 seconds. And that, at the end of the day, if you multiply everything and cancel out all the units, we're left with 60 times 5,280 divided by 60 divided by 60, and we're going to get 90 as our number, and the only units that don't cancel out are feet over seconds, so our unit is going to be feet per second. So hopefully you can see this is a really easy way of keeping track of your numbers and keeping track of your units. So you can make sure that you have your unit right, and you can make sure that you have your numbers right. So that's why this is really the best way of solving this kind of problem, because in a complicated problem like this, you don't want to have to keep track of what numbers you're multiplying by, what numbers you're dividing by, what your final unit is. This is the easiest way of keeping track of it. So hopefully this makes sense. If it doesn't make sense, make sure you come in for some extra help, because we're going to start tomorrow's class with doing some very difficult forms of these problems. So just make sure this all makes sense to you, and I will see you next class.